Today we are going to learn about optimizing Python code with decorators. We'll explore how decorators can modify and enhance function behavior, focusing on creating reusable and scalable code modifications. Welcome to our video on optimizing Python code with decorators. In this introduction, we'll briefly explore what decorators are and why they are essential in Python programming. Decorators allow us to modify or enhance the behavior of functions or methods without changing their actual code. This feature makes them incredibly powerful for implementing reusable and scalable code modifications. Throughout this video, we'll dive into the syntax of decorators, applying multiple decorators, use cases, and even touch upon performance considerations. By the end, you'll have a robust understanding of how to effectively use decorators in various programming situations. Let's get started. To begin our deep dive, let's understand the fundamental concept of decorators. In Python, a decorator is essentially a function that adds functionality to another function or method. Decorators are a very powerful and useful tool in Python since it allows programmers to modify the behavior of a function or class. Decorators allow us to wrap another function in order to extend the behavior of the wrapped function, without permanently modifying it. This is done by defining a function that takes another function as an argument, and then returning a function that usually calls that original function. This is directly related to the concept of higher-order functions, which are functions that operate on other functions. By using decorators, we can achieve reusability, making our code more efficient and maintainable. This is especially useful when we want to apply the same piece of code in multiple places but want to keep our code dry. Don't repeat yourself.
Now that we have a basic understanding, let's explore the syntax for creating a basic decorator in Python. To define a decorator, you start by creating a function, often called a wrapper function, that takes another function as its argument. Within this wrapper, you can define additional behavior, and then invoke the original function. The decorator itself is applied to a function using the @ symbol followed by the decorator function name. For example, consider a simple decorator that prints a message before and after a function is executed. Define the decorator function, then use @ decorator_name before the target function. This effectively wraps the target function, adding the defined behavior. By using this approach, you can effortlessly apply the same decorator to multiple functions, enhancing their behavior without altering their core code.
In many scenarios, you may want to apply multiple decorators to a single function to layer various functionalities. This is known as stacking decorators. Each decorator is applied in the order they are listed, from top to bottom. The decorators are stacked one on top of the other, and they are executed in the order they appear in the code. This means the decorator at the top of the stack will be the first to execute, and the last listed decorator will be applied last. For instance, consider a function that requires both logging and timing functionalities. You can create two separate decorators for logging and timing, and apply them both to the function. The order in which these decorators are applied can affect the final behavior, so it's crucial to understand the flow of execution. This technique is incredibly useful for creating complex functionalities by chaining simple, reusable decorators. Decorators have a wide array of use cases in Python programming, making them a versatile tool for developers. One of the most common applications of decorators is enhancing readability and modularity in code. By abstracting repetitive tasks into decorators, you can keep your codebase clean and focused on core logic. Decorators are also used extensively in web frameworks like Flask and Django, where they help manage routes and handle requests. Another significant use case is security. Decorators can be used to implement authentication and authorization checks, ensuring that only authorized users have access to certain functions or methods. Additionally, decorators can be employed for logging, monitoring, and profiling functions, aiding in debugging and performance analysis. These real-world examples highlight the importance of decorators in creating efficient, maintainable, and scalable code solutions.
Using decorators for logging and debugging is a common practice, as they provide a clean and efficient way to track function calls and performance. By wrapping functions with logging decorators, you can automatically log entry and exit points, execution times, and even errors. This can significantly reduce the time spent on debugging by providing clear insights into the program's flow and behavior. Implementing a logging decorator involves creating a wrapper function that logs details before and after executing the original function. You can customize the level of detail and format of the log messages based on your needs. Similarly, debugging decorators can be crafted to provide stack traces, variable state, and other useful information that aids in identifying and fixing issues. These tools are invaluable for maintaining high-quality, reliable code. While decorators offer powerful functionality, it's crucial to consider performance and memory implications. Decorators can introduce overhead if not implemented carefully, especially in performance-critical applications. When designing decorators, aim to minimize the amount of additional processing and memory usage. Avoid unnecessary complexity in the wrapper function, and ensure that the decorator's logic is as efficient as possible. Profiling and testing your decorators can help identify any performance bottlenecks. Additionally, be mindful of memory consumption, particularly when working with large datasets or in resource-constrained environments. Following best practices, such as keeping decorators simple and avoiding excessive nesting, will help maintain optimal performance and memory usage.
Decorators can also be applied to classes and methods, extending their functionality in a structured and reusable way. When using decorators with class methods, it's important to understand the difference between instance methods, static methods, and class methods. Instance method decorators are applied in the same way as function decorators, enhancing the behavior of individual methods. Static and class methods, however, require different handling due to their distinct calling conventions. Applying decorators to these methods can provide additional functionality, such as validation, logging, or access control. Class-based decorators, which are implemented as classes rather than functions, offer a more structured approach to creating complex decorators. By using the _call_ method, you can create decorators that maintain state and offer more flexibility. These features make decorators a powerful tool for enhancing class functionality and promoting code reuse. To maximize the benefits of decorators, it's essential to follow best practices in their design and implementation. Start with simplicity and clarity. Keep decorators as straightforward as possible to enhance readability and maintainability. Avoid introducing side effects, which can complicate the code and lead to unexpected behavior. Focus on reusability and modularity, designing decorators that can be easily applied across different functions and modules. Testing is crucial to ensure that decorators perform as expected and do not introduce errors. Thoroughly test your decorators in various scenarios to validate their functionality. Finally, documentation is key. Provide clear documentation for each decorator, explaining its purpose, usage, and any parameters. This will help other developers understand and effectively use your decorators, promoting collaboration and knowledge sharing within the team.
As we conclude this video on optimizing Python code with decorators, let's recap the key points we've covered. Decorators are a powerful tool for enhancing and modifying function behavior without altering the original code. They are essential for creating reusable and scalable code modifications, applicable in various scenarios including logging, debugging, and security. By following best practices, you can maximize the benefits of decorators while maintaining performance and readability. We encourage you to practice creating and applying decorators in your projects, exploring their potential to streamline and enhance your code. As you continue your learning journey, consider exploring advanced decorator patterns and their applications in larger software systems. Thank you for joining us, and happy coding.